Binary systems. Binary systems. The positive integers represented by the sequence of ones and zeros are known as the binary numbers or the base 2 numbers, whereas the base 10 numbers are known as denary numbers. Base 10 headings. Base 2 headings. Why we use binary numbers. Transistors are used by the microprocessors that identify voltage levels instead of decimal numbers. High voltage in a microprocessor is identified as an on state or a 1, whereas a low voltage is identified as an OFF state or a 0. The low voltage level is usually 0V, while high voltage varies from 3.3V to 5V. Different hardware uses different ways to identify the binary number system, e.g. in CD-ROMs, tiny black spots are considered as 0 and shiny spot represents a 1. What is a bit? The smallest representation of binary numbers can be broken down into bits. Bits in binary numbers can be considered as digits in the denary numbers. In denary numbers, a digit is a place that holds values between 0 to 9, whereas in binary numbers a bit is a place that can hold values 0 or 1 only. In denary numbers, a group of digits form larger numbers, e.g. 67 has 2 digits, 984 has 3 digits, etc. In 67, 7 holds the ones place and 6 holds tens place. In 984, 4 holds the ones place, 8 holds tens place and 9 holds 100s place. Number representation in denary. Let's take 984 for understanding the number representation. First method. 9 by 100 plus 8 by 10 plus 4 by 1 equals 900 plus 80 plus 4 is equal to 984. In this method we simply multiply each digit with the place it fills. Second method. 9 by 102 plus 8 by 101 plus 4 by 100 equals 900 plus 80 plus 4 is equal to 984. In this method, starting from right to left, each digit is multiplied by 10x. The power of 10 is least, i.e. 0, at the art.h.s and highest on the LHS. Number representation in binary. In binary, we use the raised to the power method to find out the value of the binary number. This method is exactly the same, however, instead of 10x, we will use 2x. Example. Let's find out the value of binary number 1010. Using the raised to the power method, 1 by 23 plus 0x22 plus 1 by 21 plus 1 by 20 equals 8 plus 0 plus 2 plus 0 is equal to 10. Binary to denary conversion. Converting a binary number to denary is simple, and we already discussed it in the previous heading. It involves multiplication of each bit with 2x, where x is lowest at art.h.s and highest at LHS. Just to revise it, let's take a binary number 10111. 1 by 24 plus 0x23 plus 1 by 22 plus 1 by 21 plus 1 by 20 equals 16 plus 0 plus 4 plus 2 plus 1 is equal to 23. Denary to binary conversion. There are two methods to convert a denary number to its binary representation. The first method is trial and error, while the second method involves the successive division of the number by 2. Let's understand both with an example. Method 1, Trial and Error Method. This method involves placing 1 and 0 at correct places so that the sum equals the denary value. Let's see the conversion of 107. Do not feel confused with the numbers above 1 and 0, as it represents 2x. From our .h.s, 20 is equal to 1, 21 is equal to 2, 22 is equal to 4, 23 is equal to 8, 24 is equal to 16, 25 is equal to 32, 26 is equal to 64 and 27 is equal to 128. The binary number representation contains 8 bits, standard, that's why use 2 raised to the power 0 till 7. If you see a representation that contains less than 8 bits, e.g. 1011, the rest 4 bits on the left side were zeros. 00001011 and 1011 represent the same number and both ways are correct. Method 2, Successive Division Method. Let's use 107 to understand this method. In this method 107 is divided again and again until the value becomes 0. We divided 107 by 2, it gave us 53 and remainder 1. 53 divided by 2 gave us 26 and remainder 1. 26 divided by 2 gave us 13 and remainder 0. 13 divided by 2 gave us 6 and remainder 1. 6 divided by 2 gave us 3 and remainder 0. 3 divided by 2 gave us 1 and remainder 1. 1 divided by 2 gave us 0 and remainder 1. Now that the number became 0, we can add zeros on the L.H.S to make it an 8-bit number. What is a byte in memory size? One binary digit is known as a bit while 8 binary bits make a byte. It is the smallest unit of memory in a computer. Some systems use larger bytes, e.g. 16-bit, 32-bit, etc., but memory size is always a multiple of 8. A single letter or character uses 1 byte of memory, but many special characters and characters from foreign languages use more than 1 byte. Example use of binary system. The computer system uses registers to control devices like robotics, digital instruments, and power systems. The registers are made up of binary bits, i.e. 0 and 1. Following is an example of a robot vacuum cleaner that will help you understand how registers are used to control devices. As shown in the figure above, there are 3 wheels in a robot vacuum cleaner. Wheel A rotates on a spindle while wheels B and C are fixed and attached to a motor. Wheel A also facilitates in direction changes. An 8-bit register is used to control the vacuum cleaner. If the register contains the value 10101010, then motor B and C both are on and the vacuum cleaner will move forward.